question is whether 220 volts equipment designed for a single hot leg and neutral configuration can be powered by a 220 volt supply consisting of two 110 volts hot legs. The answer is no, you cannot directly use the US 220 volt split phase to power the equipment. Here is why. The German equipment is designed to operate on a single hot leg carrying 220 volts, with a neutral providing the return path. This results in a potential difference of 220 volts between the hot leg and the neutral. In the United States, a 220 volts supply is typically derived from a split-phase system. This involves two hot legs each carrying 110 volts relative to a neutral. The voltage between the two hot legs is 220 volts, but the voltage between each hot leg and the neutral is only 110 volts. If the German equipment is connected to the US 220 volts supply, the voltage across the two hot legs will indeed be 220 volts. However, the critical difference is that the equipment is designed to have 220 volts between one hot leg and the neutral. In the US split-phase system, each hot leg only provides 110 volts to neutral, which is insufficient for the equipment's operational requirements. The potential consequences of connecting the equipment to the incorrect voltage are significant. Firstly, the equipment may not function correctly. It might operate erratically, perform below specifications, or simply not turn on at all. Secondly, there is a risk of damaging the equipment. Supplying an undervoltage can sometimes cause components to overheat or fail prematurely. Thirdly, a safety hazard could arise. If the equipment is not properly grounded and is subjected to an incorrect voltage, there is a risk of electric shock. There are a couple of solutions to this problem. Firstly, you can use a transformer to convert the US 220 volt split phase supply into a 220 volt supply with a single hot leg and neutral. A transformer essentially changes the voltage and configuration of the power supply to match the requirements of the German equipment. The transformer will take the two 110 volts hot legs and create a single 220 volts hot leg with a neutral. Secondly, you can purchase equipment specifically designed to operate on the US 220 volt split-phase system. This eliminates the need for any voltage conversion and ensures compatibility with the available power supply. When selecting a transformer, there are several important factors to consider. Firstly, determine the power rating of the German equipment in voltamps or watts. The transformer must have a power rating equal to or greater than the equipment's power consumption to avoid overloading it. Secondly, ensure the transformer is designed for continuous operation at the expected load. Some transformers are designed for intermittent use only, while others can handle continuous loads without overheating. Thirdly, consider the efficiency of the transformer. A more efficient transformer will waste less energy in the form of heat, resulting in lower operating costs. Fourthly, check the transformer's input and output voltage specifications to ensure they match the US power supply and the German equipment's requirements, respectively. Fifthly, look for safety certifications from reputable organizations such as UL or ETL. These certifications indicate that the transformer has been tested and meets established safety standards. The installation of a transformer should be performed by a qualified electrician. Incorrect installation can lead to electrical hazards and equipment damage. The electrician will ensure that the transformer is properly grounded, wired, and protected by appropriate overcurrent devices such as circuit breakers or fuses. When purchasing equipment specifically designed for the US 220 volt split-phase system, there are also several factors to consider. Firstly, verify that the equipment is rated for 220 volts operation. The voltage rating should be clearly marked on the equipment's nameplate. Secondly, check the equipment's power consumption in voltamps or watts to ensure that the circuit supplying it can handle the load. Thirdly, ensure that the equipment is properly grounded to prevent electric shock. Fourthly, look for safety certifications from reputable organizations such as UL or ETL. These certifications indicate that the equipment has been tested and meets established safety standards. Before connecting any equipment to the power supply, it is essential to inspect the wiring and connections for any signs of damage or wear. Loose connections or frayed wires can cause electrical hazards and equipment malfunction. If any damage is found, it should be repaired by a qualified electrician before proceeding. In summary, directly connecting German 220-volt single-phase equipment to a US 220-volt split-phase supply is not recommended due to voltage differences. The equipment is designed to operate on 220 volts between a single hot leg and neutral, while the US split-phase system provides 110 volts between each hot leg and neutral. The potential consequences include equipment malfunction, damage, and safety hazard. The solutions are to use a transformer to convert the US power supply or to purchase equipment specifically designed for the US 220-volt split-phase system. When selecting a transformer or purchasing new equipment, consider factors such as power rating, efficiency, safety certifications, and proper installation. Electrical work should always be performed by a qualified electrician to ensure safety and compliance with electrical codes. Understanding the nuances of different power systems is crucial for ensuring the safe and reliable operation of electrical equipment. By taking the necessary precautions and following the recommendations outlined above, you can safely power your German equipment in the US. Remember to always consult with a qualified electrician for any electrical work to ensure compliance with local codes and regulations. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Working with electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from harm. Always disconnect power before working on electrical circuits and use appropriate personal protective equipment such as insulated gloves and safety glasses. By following these guidelines, you can ensure the safe and efficient operation of your electrical equipment.